So let's bring the process one more time. In last lesson, the second hour, we ran through this loop called the problem solution loop, going this way, and we get the answer. But today, I want you to run backward. Start from the observation and verify your mathematics, your solution really solve the mathematics model, or you estimated your error between your approximate solution to your mathematics model in either way. And then you need to look at your mathematics model, correctly translate your conceptual model. That means a qualitative model. And you check each assumption and know the assumption makes sense based on the domain expertise. And finally, you check if your conceptual model really captured the essence of the problem. That loop, I call it answer at justification. Let me write better. Justification model loop. So that's the answer justification loop. In short, I call it AJL. So this loop also have 4 steps, 1, 2, 3, 4. So I'll let you to follow. I'm not going to go too much detail, but we need each step. So the first thing, you observe. Now think about a little bit in the big picture. If you finish your job in school, you give it to the teacher grade your paper, say yes or no, right or wrong, and no partial credits. That won't happen when you work as an engineer. You have to convince the other people in the domain terminology, say you did it right. Even without use any math, you need to convince your boss, your colleagues, you got it right. Well, you can make probably 1 to 2 times of mistakes, but the 3 rounds you're out. You knock out. Anyway, you are responsible for the mistakes. So in the process, step 1, we observe. And how do you observe? The good news is no engineers recreate wheels. You don't build everything from scratch. You build a little more from what already done incrementally. Then the special case of your answer should be the old answer you already have. So you have to observe some special point people already solved. You're not going to solve everything by yourself. And you can look at initial, average, median, terminal, in long-term trend, those kind of special situation that is observable. And before you go to any quantitative model, you go to the qualitative model. Don't put into number, but put into the common sense to see if it makes sense. As I told you last time, mathematics model is about insight. It's not about number, even though we use the number to do everything. So before you plug into the numbers, tell me why it makes sense. So can you explain the phenomenon in terms of domain knowledge and how much trust you put into the data you have? And can you go to the lab to show me your result is right? We're going to talk this a little bit later. Anyway, next we have the verification. And we can ask a whole list of questions here. So what kind of question? So do you have any analytical way to solve it? Analytic means like you solved in the calculus. Those solution is called analytic solution. In differential equation class, you take probably 90% of your time to find the analytic solution too. Well, if an analytic solution is not available, so you're going to have the numerical solution. But to verify the numerical solution, it's often much harder than to verify the analytic solution. We have a whole field to teach you how to analyze it. And when you learn differential equation, maybe in this course, I can teach you how to use the phase plane equation to solve the abstracted model. Well, other questions you're going to check yourself. I cannot put a whole complete list, no way, depend on what question. Before you do the verification, you need to prepare a list of questions as your project. It's a very important component. And well, I use the two words verification and validation. So what's the difference? In the software engineer or other engineer, one we call validation, we basically say you did the right thing. Basically, your design is right. You designed the thing people really want. That's validating. And the verification means you did the thing right. Means the know-how. You did it in the exact way designed. So it's a little bit different of emphasis. See, this case we call it verifying. That means my solution, my mathematics is right. I did the right thing. And the validating, I put it here. That whole process is a design, and that means you did the right thing. If a customer asks you to design a bed, you did not make it as a couch. That's what a validator is. Okay. Next, validating usually is more upstream, close to the business domain. And you need to ask, hey, you make a whole list of assumptions. Does this assumption make sense? And what is the first principle you used from science to get your equation? And what is the baseline of your situation? Did you check the units on both sides? Does the unit make sense? They're equal? Or if you identified a few unrealistic assumptions, can you remove those assumptions and make your model more realistic? That's most research are doing, is change the assumption, make it more real. The more tools you have in mathematics, the more real model you can solve. Well, the last thing, I have a long list, check the units, and try to understand the qualitative learn, and so on and so forth. I will let you read yourself.